Hello and welcome to this video on nuclear equations. I'm just going to take you through a few of the aspects of this and then we're going to do some examples as well. So, as you'd have seen from the lesson slides, looking at alpha decay, what alpha decay is an alpha particle, and an alpha particle consists of 2 protons and 2 neutrons, okay, and that gets emitted from the nucleus. So the reason this happens is that a nucleus is unstable, it wants to gain more stability, so it emits an alpha particle, 2 protons and 2 neutrons. Now that is a helium nuclei, so it's a helium nucleus without the electrons around the outside, and yeah, as I say, that gets emitted. So that does have an impact. When we're looking at nuclear equations, this is what we need to bear in mind, that if an alpha particle leaves the nucleus, and as you guys know, the nucleus consists of protons and neutrons. Well, because an alpha particle is 2 protons and 2 neutrons, that means that the mass number, the top number, will go down by 4 because the mass number is the nucleus. It's what is in the nucleus. But as you know as well, the atomic number is also known as the proton number. So as if we've lost 2 protons, that means that that atomic number needs to be reduced or decreased by 2. Okay, so the top number goes down by 4 and the bottom number goes down by 2. So don't overcomplicate it. Don't try and think too into that. It's very simple. If alpha decay occurs, you take 4 off the top and you take 2 off the bottom. And as you can see here, an alpha particle can be drawn out or symbolized by a top number of 4, so a mass number of 4, atomic number of 2, and a He next to it, which stands for helium. Okay, that's saying a helium nucleus, an alpha particle, has been emitted. So just to look at some examples of that, just scrolling down here. So we have this activity where we need to complete the following equations. So where we've got uranium here, okay, which is symbolised by the U, all right, and we can see the mass number is 238. Now this activity is an alpha decay is occurring. So what you need to do is write in what you think is happening. So first of all, very simply, we can write in 4 and 2 next to the He because we know it's alpha decay. So alpha decay is occurring and this is how we symbolise that. Now, as I said to you before, the mass number goes down by 4 and the atomic number goes down by 2. So you can quite clearly see that 238 has gone down to 234. So that means 4 has come off. And as you can see from thorium, the element has actually changed. It was uranium, now it's thorium. Now the reason for that is that the atomic number, the proton number, has changed, and that means that the element has to change because the protons tell us what the element is. So if it's gone, mass number's gone from 238 to 234, gone down by 4, that means that uranium would have gone down by 2 to get to 90. So that means that uranium, the answer is 92. Moving down to the second example. This is radon, okay? And what we've got, same example, exact same rules apply. So we've got our alpha particle that's being emitted, so we'll write that in. And what we've got here is we've got 218 as the mass number and 86 as our atomic number. So that means that this has gone down by 4. So what we do is we add our 4 back onto that. So 218 add 4 is 222. And already, so you can see from the atomic number, it was 88 and then went down to 86. Okay, so we're just filling in the blanks nice and simply. On this one, most of it's already done for us, as you can see. It's 256 going down to 252, so you can see that's gone down by 4. And 103 down to 101, you can see that's gone down by 2. So the only thing we need to do is to show that we are aware that that means that it is alpha decay, and that is what has occurred there. So that is alpha. Going down to beta. So looking at beta, what we have is, with beta decay, is a beta particle is a high energy electron. Okay, so a high energy electron is emitted, but it's not emitted from the electron shells, it's emitted from the nucleus. All right, so what happens with beta decay is a neutron in the nucleus changes to a proton and then emits a high energy electron from the nucleus. Okay, so this is all occurring in the nucleus due to the unstable nuclei that is there. So this is the gain stability. So what happens here, I'm going to say that again, a neutron changes to a proton and emits a high energy electron. So whereas before the mass number went down by 4 and the atomic number went down by 2, it's different here. Because we're switching a neutron to a proton, that means there is no change to the mass number. So that top number doesn't need to change. Where a neutron was, a proton has taken its place. So in the nucleus, a neutron was there, now it's not, a proton is there instead. And that means that the mass number doesn't change. But because we've gone from a neutron to a proton, that means the atomic proton number does change and actually increases by 1 because we've gained an extra proton. So, and you will see it symbolized like this that I'm highlighting here, or like this here. All that means is that a beta particle is negative because it's a high energy electron. So that is how you symbolize a beta particle. Okay. So, moving on to this activity here where we're looking at beta decay. And we have our first example where we've got thorium here. And what's happening, as you can clearly see, is that the mass number isn't changing, as we stated, okay, because a neutron has changed to a proton. But because we've gained an extra proton, that means that the atomic number will change. So the atomic number, as we said, goes up by 1, so you symbolise that there. On the second example, as we said, it's gone from 53 to 54, so you can see that that's already happened for us. They've shown the proton that's increased, but what we need to make clear is that we know that the mass number doesn't change. And again, where we've got helium, okay, so this is an isotope of helium, and then next to it we've got lithium. Well, we know, as we said, that the mass number is unchanged, so that is still 6, but the proton number goes up by 1. And on this example here, where we've got our beta particles again, so we just need to symbolize that as we've already described. And then where we've got our sodium, don't let this trick you, okay? So magnesium 2412, we're used to seeing sodium as 23 on the periodic table, but as I've said to you already, the mass number is unchanged, so this is an isotope of sodium with the atomic number there of 11. And finally, just a couple of examples. Sometimes you may be asked to say, is it alpha or is it beta? And really simply, once again, you should be able to work this out very, very simply. So if we're looking at this example here, the top example, you can see that the mass number is unchanged, but the atomic number has gone up by 1. That tells us that this is beta decay. Okay, and then this example here, you can see that the mass number has changed by 4 and the atomic number has changed by 2. So we know that that is alpha decay. If you've got any questions, please put them in the comments below. Give the video a like, and good luck with your studies. Thank you.